Good morning.
Good
Welcome
morning.
to Shambles College, as it is now, Shambles Stay at Home Festival. And today we have Brian Cox, but Brian Cox, due to a technical issue, is only going to appear by voice. And in fact, not even by voice. He will merely tap his answers like a circus horse. He will tap 3 times for epigenetics.
Not enough. Not enough circus horses in the media.
Oh, it is. That's the one thing. Is very often I turn on and there I see, some scientific advisor. I go, well, that's very interesting, but for purposes of balance, what about a horse that can tap out mathematics? That might give us a little bit more.
And you know what? They all get forced to predict the World Cup when they've got so much more to give, haven't they?
Well, it's very much a similar octopus situation as well, and we may well talk about the octopus with Brian as well. But Brian,
Can I just say, Robin, if it were true that a horse could tap out mathematics with its foot, that would be worthy of broadcasting, because it would be astonishing. It would mean that a species other than us can do mathematics, especially with advanced mathematics.
I know.
It might be epidemiology. It might be extremely useful.
I know. Well, also, I want to get this horse out of my house. I don't live in a big house, and during isolation, frankly, it's been an absolute nightmare cleaning up after it.
So you've got a horse. You've got a horse in your house that can do mathematics, and you've not got it on screen.
I mean, it's only just starting on calculus. This is the problem: is due to the hooves, wonderful at actually mathematics, terrible at managing to press his iPhone to get the correct connection because he's not in the same room. You see. So are you? There we are. There's
a song on Moon and Me, the children's TV show, about if there was a horse in the house. And I felt so excited to share that. And then I was like, oh, you don't have 2-year-olds. You won't care.
But you do know, Brian, you know about the counting horses that used to exist.
Oh, yeah.
Don't you? Yeah. Oh, there used to be. It was basically, it was an old trick and people would make quite a lot of money from this, which was using various different ways of getting a horse to tap out on its hoof. Correct answer. Now, what is your question? 3 + 5. Let me turn to the horse. And then the horse would appear to have done the arithmetic in its head, but actually it was through a method of training, gesture, and probably sometimes forms of torture as well. So it turned out it was not a mathematically minded horse. But for a while, there was a lot of... In the old days, that's what you would have done. You wouldn't have been working at Cern. You'd have been travelling from town to town with a horse, and it'd be called Brian Cox's Wonders of Stables. And it would have been great. So anyway, welcome to the show. We weren't expecting to get so deeply into a counting horse there. As you know, it's very erratic and it's live, and sometimes we've had sleep and sometimes we haven't. So I'll just quickly tell you a couple of things, which is coming up tomorrow. We've got Ian Rankin on. He is going to be talking about crime and pop music, the sometimes mixing the two. There may be a shaded area. And then Monday next week,
Johnny Lynch. It's Scottish special.
So Pictish Trail will be joining us as well. And then on Monday, we have Mark Gatiss. We're going to be doing all those questions that you sent in a few weeks ago. He's going to be our literary professor. I had no idea, by the way, Josie. I've been watching all of Sherlock again because my son's really into it at the moment. I had not known quite how enormous that show was. I had not known that was basically one of the big, 13 million people watched Sherlock. It was, and it's fantastic to return to it. I think I enjoy it even more, actually. But anyway, we've got Mark on next week. We've got Sophie Hagen on next week. We've got Richard Wiseman on next week. We've got loads of, so find out what's going on there. And also quickly mention again as well, we have a tip jar. And the tip jar is we have been building up over the last 5 weeks. It is now that we've been doing these shows. Over the last 5 weeks, we're building up a resource for some of the performers, musicians, comedians, artists, etc., who've been particularly hard hit by this situation, and also for some of the art centres as well, which you may well have seen. There's quite a few. The Bill Murray pub, which is a really wonderful venue where lots of great experimental things go on there, and just loads of comedy. Sorry, Josie.
Just run by very, very kind, generous, thoughtful people who love comedy and want to enable people to do good comedy and become comedians. It's such a lovely place in terms of community and spirit.
Yeah, it is, and it's and that's another one of the venues now, which looks like it's got some problems and some hope as well of staying open, but it does need support. So we are trying to find different ways of taking some of the money that we've accrued thanks to your generous donations and making sure that it's passed around to some of the smaller venues that are struggling at the moment, and we want them to exist when we are able to go out into the streets again. So, Josie, have you got a show and tell this morning? Oh, you got a sneeze. That is my favourite.
Excuse me, I'm so sorry.
So tell me, when did you first find that sneeze? Because that's a wonderful thing to show and tell.
I found it in the dawning of spring, and it took me until the winter. This is something that I painted in 2008 at the Pottery Cafe around the corner from where I used to live in Peckham Rye, and it really reminds me of a time hanging out with my friend Helen Zaltzman and doing lots of crafts. And it was her birthday yesterday. She had a big birthday yesterday. And I painted this in the style of tattoos that I didn't really know about and couldn't really at that time Google readily. And it's a mug that has kept me happy for well over a decade and very proud of it, proud of my artistic achievement. And this morning it was full of coffee. And I just put it on the bedside table there, very excited that I actually had a full cup of coffee to enjoy while we did this show. And then I went to put the kettle on to make my partner a cup of tea. And when I came in, my daughter was pouring it all down herself, drinking it and covering the mug with it.
Oh, God, you think you've got trouble. I made a strawberry milkshake the other day and I left it near my horse. It's an absolute disaster. I showed it the other day, but there is Helen Zaltzman's work as well. So what wonderful piece of work that she did. And as I mentioned, she used to be the regular xylophone player of our club night, the book club. That's a lovely mug. I wasn't sure what I was going to do. I have got this DVD box set of Series 1 Star Trek. And the only reason I pulled this out is it's one of those things, you know, when you go, oh, this is really good. It's in novelty packaging. That will never be annoying when attempting to shelve it, right? So, yeah. So it's just that thing, novelty. Is that a phaser? I think it's in phaser shape. Anyway, it's very annoying.
But you must have been very excited when you saw it. You must have thought, oh, wow. What a cool object.
It's in the computer exchange, isn't it? You go in there, they're playing death metal, that has a hallucinogenic quality for you, and the next thing is you get a really annoyingly packaged Star Trek Series 1. But what I actually wanted to show was this, which I mentioned the other day when we did our Patreon only show. Remember, if you do subscribe to us via Patreon, there'll be all manner of special treats. But this is the book that I mentioned to you, which I couldn't find, and I was just digging out the other day. And it's the Holocaust Survivor Cookbook.
Oh yes,
which I mentioned. And it's just such a fascinating, for those of you who didn't hear about it, it's a collection of recipes that were put together by Jewish people who survived the Holocaust. And so, of course, on each page, there is the description of what happened to their family, and then what happened to their life after the Second World War. And then it's connected to their favourite recipes, and it's a very there's Arlette Baron's fruit cake there, and as we were saying the other day, that kind of connection between memory, love, and cooking, it's something that's been explored.
The stuff of life. It's the stuff of life.
It is. It's really I love Zedi and Bubby's apple cake, which is great. There we go. And Zedi, he survived the Holocaust. And what I like there is, though it just says in brackets, Zedi would peel the apples. So what we know is he didn't actually get round to the cooking. Bubby would do the main work, but Zedi would be in charge. So it's a very, very, very beautiful, interesting book. The recipes, and I think also by the act of then making some of the food in it as well, that creates some sense, I think, of just a strange sense of connection with some of the stories in there. So I would highly recommend, if you are able to get this.
And it's also like a way to sort of honour someone and celebrate someone, isn't it? You're like conjuring them up. It's fantastic.
Yeah, I think it's a very beautiful book. So that's our show and tells. Me, it was the Star Trek box set, and Josie, it was a sneeze and a mug.
Mine was a cap. So we all do our own thing, aren't we?
A sneeze, a mug, and a spillage. All of them shown.
A sneeze and a mug from Josephine Long. When I was a kid, and my mum was very, very encouraging of my performing, she introduced me on some talent show, I think at church, with A Smile and a Song from Josephine Long. And I've never forgotten it. And I should use it for something because it's so sort of cheesy. But I mean,
well, that is great, because that is, the Smile and the Song, which was a great way of often introducing. But I think the Smile and the Song, Josie, is the time. It's like, you have to be careful. Some people will eventually go, look, we've come here for the song, because Chris Addison, who we had on the other day, he once called one of his shows Gentleman Scholar Acrobat, which some of you like, is from the film, is from the song The Pink Panther. He's a gentleman scholar, he's an acrobat, and he would get all people coming, like for instance he had a whole Spanish family coming who didn't speak English and had come to see this incredible acrobat. Instead they just heard a man talking about sliced mushrooms.
But that is on him, because he should have just put one flip in there unexpectedly, and people would have lost their minds. People would have been over the moon.
I would love to be able to do things like that. I'd love to be able to suddenly go into a tap dance.
Johnny's just come in the room looking absolutely stricken and said, "She's very lively." And it's because she's drunk some coffee.
Drunk coffee out of art. The two most potent things, art and coffee, have been combined. We're also joined today as well by Brian. We're joined by Savannah Clawson, who has been working out in Cern. She's Brian's PhD student. She is a physicist, and you're not in Cern at the moment, though, are you? Hello.
Hi, no, I'm not in Cern at the moment. I'm actually at home in Devon with my family, but longing to be back there when it's safe to do so.
Can I ask, so what your current research in Cern?
Okay, so I work for the Atlas detector, which is one of the 4 big Large Hadron Collider detectors out at Cern. And specifically, I'm in the standard model group. So I'm doing precision tests of our standard model of physics, because we know that basically it has to break somewhere, but we're not really sure where. So we're just throwing all the tests we can at it and trying to break it, or trying to prove that it's right again, because it seems to always be right at the moment. So that's what I do, basically. Specifically, I'm looking at photon-photon collisions. So we smash light particles together at really high energies and see what happens, which is the spirit of physics, really.
Well, this is what. Can you explain to people who don't know then what is what's the best way of explaining what the standard model is in terms of our understanding of the structure of the universe?
Okay, so the way I like to think of it is the standard model is basically our recipe for the universe. So in the standard model, we have all of these different ingredients, and these are our fundamental particles. And the standard model is kind of the list of ingredients, which are all the particles, but also the interactions between these particles, and so how they all act together. And these are the basic laws that build our entire universe. So that's kind of a very quick overview of the standard model. Obviously, it's a lot more complicated than that, but yeah, that's the essential of it.
Do you still get a sense of, because when someone was first explaining what the Large Hadron Collider did, and was first explaining generally what the experiments that had gone on in CERN over its history, it almost does have a level of magic. I know it's evidence-based magic, but the ability for human beings to collide particles at incredible speeds, to observe what happens at that point of collision. Do you still find yourself every now and again where you're immersed in actually doing the work, and then you suddenly kind of look up and think, this is pretty crazy that this is something that was not that long ago on a savannah, 10,000 years ago we're developing farming, now we're sending around particles at incredible speed, colliding and observing them?
Yeah, completely. Like every day I'm amazed by the stuff that goes on at CERN. I don't understand all of the stuff that goes on at CERN at all. It's insane. And just the sheer amount of technology and research and development that has gone in to build something like the Large Hadron Collider, or even just the Atlas detector, it's so complicated and so crazy, and I can't believe it. I'm actually a tour guide for the Atlas detector, and every time I go down into the cavern, I'm amazed all over again. It's so big and so just, incredible that I can't believe it every time I see it. But yeah.
Do you find a moment as you tour, because I know this is even with, I was talking with Carlos Frank, who's great, who's a cosmologist based up in Durham, and he was once quoted, I think it was the detection of gravitational waves. No, it was the cosmic microwave background radiation, and he was just quoted in the press as a leading scientist, and just said, Carlos Frank said, "Oh wow." Now, I think, that's a nice thing for people to know, that even, physicists who have an incredible level of understanding, there are still those, oh, wow, moments. And you must see a moment when you're taking people around and you give them one piece of information and you go and you can see there is that sudden silence and that sudden just, oh, wowness.
Yeah, completely. I think just the sheer size of the detectors is like the first oh wow moment, especially because it's a bit of a contrast because you're using these massive machines to look at like the smallest things in our universe. So they're basically like giant microscopes looking at the tiniest little building blocks of what makes up our universe, and I think that's quite poetic in a way.
Brian, you must have had, do you remember when you first saw that? Do you remember what your reaction, your sense to it was when you first went to Cern?
Well, yeah, it's interesting because when I first started at Cern, the LHC was still in construction, and Atlas was still in construction. So actually, the Atlas cavern was a giant hole in the ground when I first saw it, with nothing in it, and it's vast. I think something like the volume of St Paul's Cathedral, or the nave of St Paul's Cathedral. So it's a cathedral-sized hole, and so you see it empty. And it's wow. And then the Atlas detector went in and filled it. I mean, quite obviously, because you wouldn't dig holes are expensive, so you wouldn't dig one that's too big. So it exactly fits. The other big detector, CMS, was in fact built on the surface. It's different to Atlas, and bits were lowered down. So that was a kind of different construction. So it was very interesting to see the machine under construction. But I agree with what Savannah said. There's also one of the magical things. You talked about the magic of science. One of the magical things about CERN is that it exists at all. You go back, it was founded in the 1950s as a laboratory to bring Europe together after the war. So it was one of those optimistic projects after the Second World War. And the idea that you could build in its charter, it's an organisation which exists to advance human knowledge for peaceful means. It's in the charter, and the idea that you have an organisation, over 50 years later, half a century, that is still delivering the cutting edge of human knowledge, and it exists to generate new knowledge for the sake of it. Now, having said that, the spin-offs from CERN have been remarkable. Obviously, the World Wide Web famously was invented at CERN by particle physicists in order to share data around the world and to allow international collaboration for the advance of human knowledge. The medical technologies, particle accelerators are ubiquitous in hospitals now. People might have heard of hadron beam therapy or proton beam therapy for cancer, but radioactive isotopes with chemotherapy treatments, all those things are spin-offs from this kind of curiosity-led exploration of the universe. MRI scanners, all those things. So I think it's one of the magical things about it is, as I said, it's the very fact that it exists at all. That we still agree. The broad agreement across many countries, if not most countries in the world, certainly all developed countries, that it's worth spending money on accumulating knowledge for no other reason than it's a valuable thing to do.
Do you find it, just when you were mentioning there the World Wide Web, and you were saying yesterday, I think you were on Lorraine Kelly, and you said something reasonably anodyne, and then of course there was hoo-ha on social media. Do you think that perhaps we could bring in regulations for the internet where when you post something it says, I'm afraid this is not data? So we have to bring back some kind of data proviso for how the internet is used again to bring it back to a level of sanity.
I don't know. I think in general the idea that the freedom, the internet always was about the free dissemination of knowledge. That's why the World Wide Web was invented. Not the internet was a separate thing, but the World Wide Web in particular. So I think ultimately, a lot of people who are much more qualified than me think about these things. The way that our politics has gone, has it been influenced by social media and so on, fake news? It's obviously a very complicated area, but I think ultimately the answer, you can go back to pre-World Wide Web days and look at, for example, Carl Sagan's Demon Haunted World, and one of your favourite books, one of my favourite books. And ultimately, I think the point he makes in there is very simple, that the answer is ultimately education. That it has to be. We have to teach our citizens how to think, how to understand, to make their decisions about what is a trusted source and what isn't, to weigh different points of view, to recognise when different points of view are valid. You know, we do not live in a binary world. It is very complicated. You see it with the debate over the coronavirus. If you look at one extreme, what I'm trying to say is that the choice is somewhere in the middle. One extreme would be that you absolutely lock down the whole of society, you forget about all other impacts, and you eliminate the virus, which you could do, right? You could, if everybody stayed indoors for, I don't know what the number is, but let's say 6 months, then the virus would go away, right? However, you would irreparably damage economies, you would put people out of business, and also there are secondary problems, like people don't go to their GP to perhaps be diagnosed with cancer that could otherwise be treated, and so on. So it's extremely complicated. At the other end of the spectrum, you have the views of some rather more libertarian people who think that what you do is you say, well, 1% of people on average will die if untreated with this, or whatever the number is, 2%, and so therefore you just let everybody get it, which was essentially what happened in the Spanish flu outbreak, right, in the 1918 to 1920. Obviously, there are compromises and difficult choices to be made, and I think that. But in order to think that way, I think you have to have been taught. It's not a natural way to think, to try to see other people's points of view.
With the way that, like, we can look at different countries and see that, like New Zealand taking swift action to lockdown meant that they didn't need to do a longer term lockdown thing. They just needed to do that, and then they've eliminated it. So, like, it's tricky, isn't it? Because it feels like it's less of a debate and more of a, like, oh, some countries did the right thing and some countries really made an error here. And
fiendishly complicated, though. You know, I mean, there are other ways you can do the very aggressive testing and contact tracing and all that. I mean, I'm not an expert, but what I do recognise is I do not envy the policymakers and people who have to make decisions, because it's unprecedented and it's fiendishly complicated. But that's the point. The point I'm making is the world that we live in the 21st century is fiendishly complicated, and I don't think that there are any simple answers to the problem of fake news and the violence or otherwise of debate. I think online and I think that ultimately it's about education.
Robin Ince has left. I mean, it's absolutely. You've had a profound effect on him with that comment, and I think he's been full stop. I completely agree. I wish that, as a matter of course, everyone were given more education in things like critical thinking and reasoning and tools, so that they can critically appraise things, like media studies that get so divided, but actually learning to read what is appropriate and what is not, and what is learning to sort of decode the media, who's saying what and why, is so useful and so important in trying to kind of navigate such difficult circumstances.
Yeah. I suppose I should take over in the absence of Robin. So I'm going to ask Savannah.
Take over.
And thankfully, discovering the Higgs was just the first step in the story, luckily for particle physicists. So basically, we found the Higgs boson, and that was kind of the missing piece of the Standard Model. It was predicted to exist decades and decades ago, but we hadn't found it. So we'd been looking for it, and then it was discovered back in 2012 at Cern. And But now we need to actually test this particle that we found, because we don't know if it's necessarily the exact Higgs boson that's predicted by the standard model. So we're doing loads of precision tests of it to see if it interacts in the way we expect, to see if it decays in the way we expect, and things like that. And yeah, other things that are going on as well. So there are things that we don't understand, for example, like dark matter. That's a big one. So we know that there is this thing called dark matter out there in the universe, but we have no idea what it is. We know that it must interact through via gravity, but we don't know what it consists of at all. So that's a big thing that we're looking for as well at the moment. So there are lots of ideas that maybe weakly interacting massive particles are dark matter. So we're looking for if these particles might interact with the standard model at all, and if we can see them and detect them at the LHC. So that's just some of the ways that we're going and things we're looking for at the moment.
And can you describe what, there might be people listening who think, I quite like to do a PhD. Can you describe what it entails? I mean, now you're at Cern for this year, 18 months or so, doing research. So what does it mean to do research at Cern?
Yeah, so for me, I basically do data analysis on the Large Hadron Collider data. So what that involves on a day-to-day basis is writing a lot of computer code to analyze all of the data. So generally, it's kind of like having an office job. So I'm doing research, I'm sat at my computer writing code. But on a larger scale, working at somewhere like Cern, it's such a massive international collaboration that you get to meet people from all over the world. I work with people from America, from Europe, like from everywhere basically. And that's one of the great things about working at Cern, is working in such an international environment. Also, we get to the opportunity to be tour guides at Cern. So like I was saying, for the Atlas detector, which means I actually get to go and see the big thing that takes all of my data, which is pretty cool. So that's what my general day-to-day involves at the moment. Well, not at the moment because I'm at home in Devon, but usually.
We've had some people email in questions that they'd like to ask you both. And Robin's back as well, or he was back, but he's frozen up now. But we get a nice picture of Robin. Stay-at-home academy. 6-year-old Edith has got a question, which is very cute, which is, what is the Milky Way? But I suppose people know, but it would be nice to explain to her. Oh, yeah. Robin's gone again. But we've got a good question from John as well, which links in, I suppose, which is that if you had a choice of one galaxy to visit in person, which would it be and why? And how far away? So yeah, we have lots of cute questions like that.
Yeah. I feel like Brian should take these ones as the astrophysics documentary guy.
So the first one is, what is the Milky Way? It's actually a very good question. I think it's part of the key stage, whatever it is, syllabus now, which is really interesting. But it's so at one level, it's the stars. So the bit we see are the stars that shine. It's our galaxy. And there are something like 200 billion, perhaps anything up to 400 billion stars in our galaxy. So it's actually an active area of research, just how many stars there are, because it's hard, because we're looking at the galaxy from within. So it's quite hard to map it. But it's basically an island of 200 billion stars, let's say. But actually, that's only about probably something like 5% of the mass of the galaxy. Most of it, as Savannah said, is dark matter. So probably 85-90%, again, active area of research, is dark matter, which is probably some kind of particle that we haven't yet discovered. We're hoping still to glimpse that particle, to discover it at the LHC. But it's some kind of particle that interacts very weakly with normal matter. That's 85-90% of it. And actually, the other 5-10% or so is dust. So there's more dust in the Milky Way than there are stars and planets. So that's the answer. A huge island of dark matter with a few little things hanging off it, like a sort of condensation on a spider's web in the morning. And those little things are stars and solar systems and us.
That's a very beautiful way of putting it. It's really evocative.
Can I just ask, because as I've only just joined, was that Edith's question, 6-year-old Edith's question? I thought it might be. I only caught the end of that. That's great.
There was a second question as well, wasn't there?
Yes, it was. If you had a choice of one galaxy to visit in person, which would it be and why, and how far away is it?
But I tell you what, I'll give you the answer first, and then Savannah. I would say if it's a galaxy far, far away, it'd probably be Star Wars. Having said that, it's not a very relaxing place, is it? It's in constant turmoil, so I'm not sure. Maybe this one, because this one has got our beautiful planet in it, and it's a nice place to be.
Yeah, this is a question I've never really thought about this before. It's a good question, but I'm not sure what galaxy I'd visit if I had the choice. But they're all very, very far away, so I think that's the problem at the moment. It would take quite a long time to get there. So I think one of the closest ones is something like 25,000 light years away. So that means it would take light 25,000 years just to get there, and I can't travel that fast, so it'd take me quite a lot longer. So that's the first problem I've got to overcome.
So that's an experimental physicist's answer, right? It's not which one do you want to go to, because theoretical physicists will go, oh yeah, well, we could roam the universe, but it's a good point that we're never going to get to another galaxy. I'm sure we're never going to get to another galaxy. I mean, it's actually the Andromeda galaxy, the nearest big one, is about 2 million light years away, which is the nearest large galaxy, although there are smaller little satellites of the Milky Way. But we're not going to any of them.
But I think you're allowed to dream, because this is like if somebody said, if you could live anywhere in the world, where would you live? You can't go, well, I'd have to do my job, so I couldn't live any.
Yeah, sorry, I gave the boring answer.
It's not. It's engineering. It's engineering and experimental physics. There's some things you just can't do.
But also, it gives more interesting information surrounding it to people as well. It's important to understand the actual dimensions of these things.
This is quite a good link into my show and tell as well. So my show and tell is also a coffee mug. So this was my Secret Santa gift this year from the Manchester Particle Physics Group. So first of all, we've just got the standard model of physics on one side. The Higgs boson is missing, I realised this morning, but we've got all of our quarks and all of our leptons down here and all of the force carriers here. But the best part about it is on the other side, we've got galaxy and also Brian in the Earth. So this is my show and tell for today. So there's
Brian actually creating the Earth there. Yeah. I'm not saying that it's given him godlike abilities, but that mug may suggest there is potential.
Yeah, I'm not sure where on the internet this was found, but it's a bit Deepak.
It's a bit Deepak Chopra, isn't it? It's a bit,
you've got it's the hands. It's the way that you're the whole world in his hands. He's got the, it has that. It's there's a song and everything.
You're going to sing. Maybe Josie can give us that song.
Well, Josie very much does a smile and a song.
Smile and a song. Happy to oblige.
While I was away, did you ask Hayley, age 9's question, by the way? I'm not sure if you got this one. No. This was from the other day. Hayley, who her mum would also like to mention, Brian, that Hayley thinks you have a lovely smile. She's just finished watching the planets, 9 years old, and she would like to know, are all of the planets in the TRAPPIST-1 system tidal locked, or just some? And which one appears to be most likely for life, in your opinion?
So TRAPPIST-1, I think, is the just going to check, is the planetary system around a red dwarf star, and if that is correct, it is. So yes, they will be tidally locked. And what tidally locked means is, so our moon is tidally locked. So you might think, well, it's strange, isn't it, that we only see one face of the moon, because the moon is spinning on its axis, as is the Earth, and the whole thing is choreographed seemingly miraculously, such that the orbit of the moon is synced up with its spin, and so we only see one side of the moon. But that's actually a natural consequence of gravity and the way that gravity works. So over time, if you've got a planet orbiting very close to a star, and all planets around red dwarfs are orbiting close, then they will tend to, over time, get into this so-called tidal lock scenario. And Mercury is another one. Mercury has a very a more complex relationship, but a relationship between its spin rate on its axis and its year, which is the time it takes to go around the star. So yes, as far as I'm aware, because all the planets are very close to the TRAPPIST-1 red dwarf star, which is a very small star, they're all tidally locked. And then what was the second part of that question?
Oh, the second one was, and which one appears to be the most likely for life in your opinion, which I imagine will be a slightly more problematic question.
Yeah, it's interesting because several of the planets, as you rightly say, in that system are what we could say potentially Earth-like, in the sense that they're rocky planets, the right distance from the star to if the atmosphere is right and the conditions are right to support liquid water on the surface. So that's the so-called habitable zone. And there is a habitable zone. It's much closer to the TRAPPIST-1 star because it's a small star. So it's a very dim star. So the habitable zone is closer in. Because this whole system, by the way, would fit inside the orbit of Mercury if you overlaid it over our solar system. So they're very close to the star. But there's a big debate, and this requires climate modelling and so on, about whether a planet imagine that the Earth always presented one face to the sun. So imagine that let's say the bit around from Greenwich, the Greenwich meridian outwards to some longitude, always pointing towards the sun, and then the other side of the world always was perpetual night, always pointed out into space. So the atmosphere would transmit heat from the day side to the night side. So there's a very interesting question about whether that system is stable enough, that planet is stable enough to support oceans, let's say, or lakes on the surface, or life on the surface. And the answer is not known, I think. That a lot of people model it, but you can imagine how difficult it is to model the climate of a planet where one face always points towards the star. So the answer is we don't really know yet. It's one of the reasons these places are fascinating. And the other thing I'll just say is that most stars in the Milky Way, to go back to the question earlier, are red dwarfs. So we say things like I think 1 in 10 of the stars in the Milky Way, on average, has a rocky Earth-like planet around it somewhere. It's 20 billion. That means 20 billion Earth-like planets, potentially. But most of them, of course, are around red dwarfs. And so many of them will be tidally locked. And so are they places where complex life could develop or life could emerge? We're not sure.
Brilliant, thank you. I'm not sure if have you asked Giles's question, Josie, about what could parents be pointing out to their children with materials available in the home? So I think that's because a lot of people are homeschooling. In fact, I think the reason we've got a technical issue with you and the reason that I crashed out is both because our children are currently doing all their internet homeschooling work at the moment. It's much easier during the Easter holidays. But yes, looking at things around the home to try and build up or question things about the universe and use for science. I wonder, Savannah, is there anything you particularly think is useful for people at the moment?
So I was actually the University of Manchester have a really good physics outreach team, and they've been doing this thing on social media at the moment where they're encouraging everyone to do physics at home experiments. So I can try and find all the links so that you can give them to people. But basically, they've been getting all of us that are involved in the outreach group to do our own physics at home experiments. So I've been nominated to do it and I haven't yet. So Tony, I promise I am going to do it soon. So I'm going to make elephant's toothpaste. I don't know if you've ever seen that experiment done before. So you can do it generally with stuff you've got around your house. I've actually got a whiteboard here that I've written for when I do my experiment. So what you need is basically like yeast and some warm water, some washing up liquid, some food colouring, and then hydrogen peroxide solution, which you can buy generally in pharmacies and things like that. And then you mix it all together and it creates this chemical reaction basically where all froths up and expands and becomes what looks like giant toothpaste essentially. So that's an experiment you can do at home. But yeah, the physics outreach group at Manchester are really, really good, and they have loads of cool little experiments like this that you can do with stuff you find around your house. So that's a really good resource, and I'm sure loads of other unis and places have things like that as well.
There's a fun thing to make as well. You know Oobleck?
Yeah.
That's
good fun.
I think we did ages ago on Radio 4 did a show called The Science of Dr. Seuss, and Mark Miodownik from University College London. We a bit of corn flour and a bit of food colouring, and you've got Dr. Seuss's Oobleck, magical Oobleck.
Very, very messy though, so definitely put some newspaper down or something if you're going to make Oobleck. Yeah,
you're right. It is. I was lucky. I did do it in laboratory conditions. Brian, what about you? Have you, in terms of those things around the house, in terms of ways of finding different ways of people connecting with scientific ideas, is there any advice you would give?
Well, I mean, I could publicise the initiative I've been involved in, which is with the BBC, the Bite Size initiative. So if you go online, and I know that my son at the moment is his school having him use some of those resources, and they're being broadcast all the time. They're on the red button. They're also online, and there's a whole lot of background information as well. So if you are homeschooling, that's what I would call a trusted resource. So it's one of the problems I think many parents have is, and I have the same problem in subjects I don't know much about, is I could go online if part of the schools say, well, can you learn about I don't know history, that 15th century monarchy in Britain or something, then I could type that into Google, but who knows what will come up, right? I don't know whether so that idea of a trusted source, I think, and as Savannah said, also the universities. So if you go to a university site, or you go to the BBC, or you go to some kind of accredited site, that's the way to do it, I think. That's the advice I would give.
It's interesting, isn't it? Because I do know that, Google's algorithms and system now is much better in terms of being, but it was interesting the other day talking to Matthew Michael Marshall from Skeptics on Merseyside, where he was saying YouTube still has a very erratic system that means that if you are looking up scientific information and you put in a phrase, you may well, the first 20 results may be utter balderdash. So I think, in particular there, but you're right. I think using, again, critical thinking, working out where this resource is from, why it's been made, and all of those things is a very important part of it.
Basically, if it ends in .ac.uk, you can trust it. Number one, that's a good starting point.
And I just mentioned, I think we'll probably wind up now because we've had quite a few technical difficulties today, and we will, as I said, hopefully back 3 p.m. on Sunday. We'll be doing the regular Sunday Science Q&A, and with luck, Brian will be joining us on that on screen as well. And remind you of the tip jar as well, which is at the bottom here, which is to collect a fund for various people in various venues that have been hit hard by this. And Josie, you've got your hand up. Yes.
Also at 12 o'clock, I'm going to be streaming my show Tender, which is my stand-up show that I was supposed to be performing in Sydney this weekend. So instead, I'm going to be performing it in my living room / kitchen / dining room.
But in an Australian accent for the whole thing.
Yeah, please, if you fancy it. 12 till about 2, a little interval in the middle.
Well, last time I saw you in Sydney, it was a really great show as well.
Oh,
so I think it was a really good show when I saw you out there. So we'll be back tomorrow morning as well with Ian Rankin, and we will then be back. We've got Sunday Science Q&A, and Monday we've got Mark Gatiss, and in between there's the Children's Science Show on Saturday as well. Lots of stuff going on. We're starting to rethink what we're actually going to do over the next few weeks. Now we've been doing this. By the end of next week, it'll be 6 weeks. So if you have ideas or things you'd like us to do. Yeah, 6 weeks. By the end of next week, 6 weeks. So we're planned out with this as a kind of structure for the next till the end of next week, which will be 6 weeks. If you've got ideas of other things you would like us to do, then please get in contact and tell us. The final things I wanted to quickly ask, because you mentioned this again, I think, on Lorraine Kelly the other morning, but the sky at the moment is, as you know, a lot of people have a lot more time to look up at the sky. And this is a very good time, it seems, as well. Last night, when I was looking around at various different things, Elon Musk taking over the sky, which worried me, though, because I watched Day of the Triffids the day before, the old 1981 TV series. And, of course, you look up the lights in the sky then, and everyone goes blind, and it's a dystopian future where the plants take over. So I'm still a little bit careful looking at the sky. But, Brian, what at the moment are the most exciting things that people should be looking out for tonight?
Well, I think virtually everybody's been noticing Venus in the evening sky. It's the brightest thing in the sky. It appears even before the light has gone after sunset. It's so bright, and it's but then if you really want to, there's a spectacular show in the morning. If you get up just before dawn, so let's say 4 a.m. or something, I think maybe 5 a.m. So before the sun rises, you'll see Jupiter, Mars, and Saturn all in a line in the east, sort of east southeast, and they're quite close to the horizon at that time. So it's better if you've got a pretty clear horizon to the east. But you'll see those, and they're rising in the morning, and they're beautiful. And you can see, if you've got a good view and you're away from city lights, you'll see the colours. So you'll certainly see that Mars is quite red. And it's nice to see 3 planets in a line.
So that's about 4 a.m. is the best time to 4 to 5 a.m.
Before dawn. Yeah.
Tell you can see that. My friend Nell Frizzell, who wakes up every morning criminally early just because she's so full of beans.
And we should have her on this as well.
Oh, my dream. I would love that.
We should do a live
Savannah.
one. Live planet spotting at 5 a.m.
Beautiful.
Yeah, for people in Australia. Yeah.
Savannah, is there anything in particular that you've had? Because again, I think it's been an interesting time where we've been able to focus on certain areas more specifically. Is there anything that has really caught your eye?
So I know the Starlink satellites have been visible recently, haven't they? So that's really cool. And there's also the Lyrid meteor shower. I think that peaked on Tuesday, but I'm not sure if that's still visible at the moment as well. So yeah, lots of interesting things to look out for at the moment, definitely.
Oh, well, thank you very much for joining us, Savannah. And thank you, Brian Cox. And we'll see you as well on Sunday at 3 p.m. And Josie, so midday
till 2 with a little break in the middle for me to drink a cup of tea.
Brilliant. Thank you very much for watching, listening, whatever you've done. All of our previous podcasts with so many different guests that we've had on, all of those are also available. You can just listen to them as well. You can check out various different sources, SoundCloud, etc., where you can find the podcast versions of these shows. Thanks very much for those of you who've been able to leave something in the tip jar. I know not everyone is able to, and that is absolutely fine as well. But thank you very much for those who are contributing to that as well. And thank you everyone else for contributing your questions and all those other things. See you at 10 o'clock tomorrow morning with Ian Rankin and the Pictish Trail.
I'm excited about that.